Thank you very much. It's a pleasure to be here.
We in General Motors welcome the opportunity to go out and talk on this subject with, especially with student groups and on campuses. There has been so much written and said about air pollution, especially with regards to automobiles. There's probably as much misinformation as good information about it. And we're anxious to go out and talk to groups whenever we get a chance in hopes that good information will drive out the bad. I was explaining to some of the others before that I'm not an expert on any technical aspects of automobiles or air pollution control systems on automobiles. As I said, I'm a public relations man. About a year ago, about 18 months ago more exactly, when interest in the environment activities began to pick up, we received many requests around the country for people to come and talk about what we were doing about the automobile and air pollution. Initially, and for probably quite a bit of time prior to this even, we felt this was a very technical subject, very complex, and it should only be talked about by technical experts. It soon became apparent to us that if we were to answer all the requests that we had, which we were anxious to do, there'd be nobody back in the laboratory working on solving the problem. So they undertook a program to at least educate somewhat some of the field people that work away from Detroit in the various cities, and especially members of the public relations staff, as to what we were doing in this area, and so that we could go out and fill some of the requests. We realized that just saying that we were too busy was kind of begging the question. Most people tended to think we were just ducking the issue and didn't want to talk about it. So, although I'm not a technical expert, they pass on a lot of papers, technical papers and other kinds, and we've got some background. I don't have a long speech tonight because I much prefer to find out what's on your mind and to discuss back and forth various aspects of this subject. I think that that's usually a lot more benefit to everybody than just a speech. There are a few things, remarks I've prepared that I would like to say. Perhaps they can serve as a platform for our time for questions. And I would also like to say that although I perhaps can't answer technically all the questions you might have, we are, and I am prepared to get the answers to any questions you have. So if we come on one that requires more technical background, perhaps we'll be able to write down your name and I can get an answer back to you. Over the past week or two or so, there has been much commentary in the newspapers and on television of the effect of Earth Day 1970. I saw particularly a special on CBS with Walter Cronkite, and I think it was fairly typical of some of the other things I've read. The conclusions that were drawn were, like so many other aspects of our life today, mixed. They had mixed results, mixed opinions about the success or failure. There had obviously been some progress made in certain areas and no progress made in other areas, and a little progress made in some others. Everybody did agree, I think, on one thing, that there's a big job to be done. Much still remains to be done, both in learning about various kinds of air pollution and in solving these immense problems of environmental pollution of all sorts. Unfortunately, there are many people who feel that Earth Day 1970 was a failure, and they've given up all hope of solving our pollution problem through individual efforts by ordinary citizens. 2 weeks ago, I was a part of a panel discussion in Milwaukee that included a student, an ecology student from the University of Wisconsin. He told the audience that it was his opinion that people will never do what is necessary to clean up the environment of their own volition, and he advocated turning the entire job over to the government. I just thought that that was a rather disappointing, hopeless viewpoint to have for a young man of 21 with most of his life ahead of him. I think personally that Earth Day last year did have some successes. One of the biggest pluses of last year's activities, I feel, was in the fact that it brought pollution problems in our country to the attention of so many people. It also brought out the fact that pollution, like so many things occupying our attention these days, is a big problem. Unfortunately, we find that many people are unwilling to face the fact that big problems require big solutions, and big solutions do not happen in a big hurry. We simply do not have any magic wands that we can wave around and bring about an instant change. There was one of the very active environmentalists, I guess is what we can call him these days, Joseph Karagannis in Chicago, is a young man that's an attorney, has been very active in pollution control things in the Chicago area. And he was interviewed in the paper the other day, and he said it was unfortunate that it seems to be the American way that people see a problem, they get concerned about it, and in his organization they called and they wanted to know what they could do. And they wanted to do something right then and now. They wanted to do it on the phone or in the next 10 minutes or the next 20 minutes, or they would maybe even take a weekend to work on it. And then they wanted the problem to be solved, and they've done their part in solving it, and it's over with, and we'll get on to something else. Well, we know that it just doesn't work that way. It's obvious from anyone that's studied the problems of various kinds of pollution that they're not going to go away that easily or that quickly. And the job of arriving and reaching solutions are not going to happen that easily and that quickly. They're going to take the constant attention of a lot of people for a long time. However, I think that just as Earth Day 1970 dwelt on bringing the nature and the scope of the problem to the public's attention, in my opinion, Earth Day 1971 should be devoted to discussing solutions. And that's what I would like to do tonight, particularly with respect to the automobile and its portion of the pollution problem of the nation. While many people became aware last year or in the last few years of the role of the automobile in the air pollution problem of the nation, General Motors and the auto industry has been aware of it for quite some time. The fact that what comes out of the tailpipe of the car, although usually invisible, can mingle with the atmosphere and create photochemical smog was first discovered in the early 1950s. And following that first discovery, we began work towards isolating the nature of photochemical smog, what caused it, and we began work on how to solve that problem or how to eliminate photochemical smog. And unlike some of the doom and gloom people that surround environmental movements, we have a great deal of hope and confidence in our ability to solve this problem. Our engineering and research scientists feel we are on the verge of eliminating the automobile from the nation's air pollution problem. Now let me hasten to add that by eliminating the auto from the problem, I do not mean building an auto that has zero emissions. We know of no vehicle propulsion system that is a zero emitter. What I do mean, and what we do intend to do, is to control emissions from automobiles to the extent that they are no longer in such quantity as to be considered harmful. Let me cover briefly some of the history of our work in this field. I'm sure that if you're interested enough in this subject to be here tonight and to be active in this environmental movement on this campus, that you're probably familiar with much of it. But for those that may not, let me backtrack a little. There are 4 types of pollutants associated with automobiles: hydrocarbons, or unburned fuel, carbon monoxide, oxides of nitrogen, and particulate matter, particularly lead. There are 4 places from the automobile where these pollutants can escape into the atmosphere: the crankcase or engine block, the carburetor, the fuel tank, and the tailpipe, the exhaust system. The positive crankcase ventilation valve was first installed in all our cars in 1963. It eliminated the crankcase as a source of pollution by routing unburned hydrocarbons from the crankcase back into the engine for reburning. Carburetor changes, changing in the timing, retarded spark timing of our ignition systems, the air injector system, the control combustion system, all these pieces of equipment installed in our cars nationally in 1968 brought about reductions in emissions from the exhaust system of the car. Our 1971 model cars have an evaporative control system which has eliminated evaporative losses of hydrocarbons from the fuel tank and from the carburetor as sources of pollution. Now, what has been the effect of these controls? In 1960, a vehicle with no control system at all on it, on the average, was said to emit 567 grams of hydrocarbons per day. With the 1968 control systems, these emissions of hydrocarbons were reduced to 239 grams per day. And early field testing of our 1971 products now in use indicate that these emissions have been reduced to about 75 per day. So we have reduced hydrocarbon emissions by about 80%. With respect to carbon monoxide emissions, an uncontrolled vehicle in 1960 emitted about 2,500 grams per day, 2,500. By 1970, this figure had been reduced to 960 grams, and this year, our early tests indicate a further reduction of about 200 grams, or approximately 70% of the carbon monoxide has been controlled. The elimination of lead particulate emissions in the exhaust stream will come about and is coming about with the use, the advent and the use, widespread use of unleaded fuel. Oxides of nitrogen, with the present controls, has now been eliminated. We now eliminate approximately 60% of the oxides of nitrogen. Further reductions of NOx are proving to be the most difficult achievement for our engineering people, and I'll go into that a little more later. Now, what does all this mean about the quality of the air most of us breathe? This is really what we want to get down to. Well, this is an area where there is a great deal of confusion, disagreement among scientific people and government and industry officials and critics and public in general. And although I said at the outset that I would rather discuss solutions than get into this nature of the problem, let me touch briefly on this so you'll have an idea of what we're talking about. It is, first of all, an almost impossibly difficult job to precisely measure the makeup of the air across the entire country. The chemical constituents of our air are described in terms of parts per million or grams per mile, in some cases even parts per billion, just incredibly minute numbers that are certainly beyond my imagination. Now, if you add to this the fact that the air obviously differs greatly, the makeup of it in different parts of our country, and is affected by geography and terrain and climate and altitude and a lot of other things, and also by the fact that there is very limited measuring equipment available throughout the country, you get an idea of the size of the measuring problem. Nonetheless, there has been 2 published federal surveys on air quality that are generally accepted. In 1966, the government said that on a basis of tonnage, the auto accounted for about 60% of the total amount of pollutants put into the atmosphere daily. Now, if I understand the system correctly, this figure was come at by deciding on how many grams per mile were emitted by an automobile, and then determining the average use of a car on a given day by the so-called average American. It's one of my favorite people. He's one of the most famous people I ever knew, is the average American. And multiplying it by the number of cars, which is the one exact number in the whole formula that we know. We know how many cars are registered in the country. And that was done on a tonnage basis. They said the auto accounted for about 60%. Revised estimates as of 1968 put that figure at 38%. Now, unfortunately, there have been no official federal estimates published since that time. This 1968 study was published in 1970. That would give you an idea of the enormity of the measuring problem. It takes quite some time to assimilate this information and interpret it, I guess, and add it up or whatever they do with it. However, we feel it's reasonable to conclude that with the addition of more controls on our cars in 1968 and 1970, and again this year, that further gains have been made. I'm not really interested in, as I said, arguing how much or how little of the problem belongs to automobiles. We intend to take care of pollutants from automobiles no matter what share of the problem is ascribed to us. Probably what you're more interested in hearing about is the future, the next generation of pollution control systems. General Motors engineers believe that the sophisticated equipment that we're planning to install in our vehicles in the near future will make the internal combustion engine virtually pollution-free. Now, as I said, that does not mean it has zero pollutants or it's a zero emitter or however you want to put it. That means that we feel we can control hydrocarbons by about 95%, carbon monoxide by about 85%, and oxides of nitrogen by about 80%. Our target for reaching these levels of control is late 1974, when we begin selling our 1975 products, which traditionally takes place in September. Now let me tell you a little about the type of control system we're talking about. While the final determinations on all the components have not yet been made, I can give you an idea of some of the strong probabilities that will be part of it. First of all, of course, we'll retain our present evaporative control systems that cover the fuel tank and the carburetor. We'll retain the blow-by crankcase ventilation valve system that covers the unburned hydrocarbons from the crankcase. We will have an improved carburetor system with an altitude compensation mechanism in it and a power choke mechanism that will be part of a sealed carburetor that we will begin installing on our vehicles on a limited basis in the next year. We may also have electronic fuel injection on some of our different cars. These this carburetor and fuel injection is designed to more precisely monitor the air and fuel mixture that goes into the engine, which is the best way of getting the most complete combustion system, complete burn of your fuel, and the first place that you can eliminate hydrocarbons from the whole exhaust stream before it becomes exhaust. We're also testing gas recirculation systems that would work to send some of the exhaust gas back through the engine and would serve to lower the combustion temperature. And this would reduce the formation of oxides of nitrogen. Oxides of nitrogen are created when oxygen and air are mixed at high temperatures. The higher the temperature, the more oxides of nitrogen you produce. The key element in our system will be a type of catalytic converter, and you may have heard about this. The function of a catalytic converter will be to convert unburned fuel, hydrocarbons, and carbon monoxide into water vapor and harmless carbon dioxide gas. This will be done as the exhaust stream is passed through a bed of pellets prior to its going out the tailpipe of the car. The converter mechanism, the converter will be embedded halfway in a muffler-like piece of equipment somewhere under the middle of the car, let's say, somewhere along there, just as your present muffler is, and it will work its chemical reactions on the exhaust prior to its leaving the car. Now, while we have not yet selected the type of catalyst we will use, the type of material, we have an extensive program to test various kinds of catalysts going on. This program is being done both within General Motors at our research laboratories and with some of our division staffs, research staffs, and with outside suppliers. To date, we have received proposals from 31 potential suppliers, including some of the major chemical companies in the country, some of the major oil companies in the country, and people that have got long history in this field. Between the outside suppliers and our own staff activities, we have tested more than 200 different kinds of catalytic materials. So we think we're trying every way we can to uncover the right process. As I said, we haven't selected exactly what type of catalyst we're going to use. What we are looking for will be a non-noble metal which will function at a low temperature, which will begin to work rapidly as soon as the car is started, which has a high conversion efficiency for converting the unburned fuel and carbon monoxide, which is readily available in a sufficient quantities to supply our needs, and one that has a satisfactory durability factor in it. That it is our opinion that based on the work we've done so far, while we haven't said what the catalyst will be, we have several possibilities. In fact, we have, I think, about a dozen that meet most of our requirements. I think the biggest problem in determining exactly what catalyst we will use is that, in saying exactly what catalyst we will use, is that first of all, we're not to the deadline yet that we have to make the decision. And if you know anything about research and engineering people, they rarely like to make a final decision as long as they still have time to put it off. They're never finished testing, they're never finished examining. There's always one more thing they could do. So as long as they haven't had to say, the management hasn't gone to them and say, you tell us today or it's too late, they'll keep testing. Obviously, one of the factors in conducting more and more extensive tests on the catalyst that we know will work is the durability factor. We found that no matter how closely you can run a laboratory situation to compare with an actual use situation, there just is no substitute for actual use. When you're talking about testing a catalyst that will work over a certain number of miles, and the goal here is 50,000 miles. You can run an engine on a dynamometer in a laboratory 24 hours a day and simulate the driving. And you can say you've gone 50,000 miles. That isn't the same as running a car 10,000 miles a year for 5 years. Well, we know we can't run one for 5 years before we decide how it's going to work. But we do like to take, do want to take as long as they can to do as much actual on-the-road testing of this equipment and these systems before reaching a decision. And as I said, we feel that this system will make the internal combustion engine virtually pollution-free. Development of such a group of control systems will not end pollution control work at General Motors by any means. I want to assure you that. There is still much improvement to be made, especially in controlling oxides of nitrogen. Standards setting strict control of NOx will take effect in 1976 on a nationwide basis. There is much to be done before we will be able to meet these standards. At the present time, in fact, we just do not know how we will meet the standards controlling oxides of nitrogen. We have discovered problems about oxides of nitrogen that we just don't know enough about. We just haven't got the answers on all the causes of it. We have found that as you begin to do certain things to the engine to lower the formation of carbon monoxide and hydrocarbons, oxides of nitrogen begin to increase. This is obviously a serious dilemma as to how we're going to do both within the same program, and it's something that we still have to find a way out of. There are a number of avenues being explored towards this goal. A second catalytic converter is one thing that is being prominently looked into with a different kind of catalyst that works best on oxides of nitrogen. Various kinds of exhaust recirculation systems are another form of at least controlling the combustion temperature and inhibiting the original formation, the initial formation of oxides of nitrogen. That, first of all, is one avenue that still remains to be explored. We have not, by any means, ended any programs to develop a different kind of engine, an alternate power source, call it what you will. You're probably aware that we've purchased the rights to study and develop and build and sell, if we choose, to the Wankel engine. This has possibilities in this area. It's another place that we still have another item that we still have a lot to learn about. We will begin selling in the fall for heavy-duty uses a gas turbine engine. And many of our scientific people feel that some version of a gas turbine engine adapted for automobile use would be perhaps the engine of the 80s, if you, so to speak, that's sometime down the road based on what we know of it now. But there are big, major problems to be overcome with that engine before it's adaptable for automobile use. In conclusion, I just want to assure you, and probably the principal reason that we're glad for opportunities to talk at places, campuses and places like this, is to assure you that we are working very hard to solve this problem. We are very serious about solving it. We have stated that we intend to eliminate the automobile from the nation's air pollution problem. We are spending many millions of dollars and many thousands of hours, hundreds of thousands of hours of manpower towards reaching this goal, and we don't intend to stop until we have what we feel is a virtually pollution-free automobile, and we have eliminated the automobile from the nation's air pollution problem. Now, if we have any questions or subjects that you'd like to discuss, I'd be glad to get on with them. Go ahead.
If I might divert a moment from the air pollution situation, we have some ecological concerns as well about such things as fuel economy and the number of automobiles and clogging the roads and actually the number of roads. I was wondering, is General Motors doing anything on research of other modes of transportation, specifically public transportation, and also on fuel economy?
Well, on public transportation or mass transit, first of all, we certainly do a great deal of research on that because it happens to be a big portion of our business. We make, manufacture, and sell most of the buses in the country. Somewhere about 80% of the buses in the United States are made and sold by General Motors. We also manufacture and sell most of the locomotives in the country. While people don't generally think of it or remember it, we're in the transportation business. That's, first of all, what we're talking about. And any altruistic reasons we might have aside, we have very good business reasons to be interested in keeping the railroads alive and the bus lines alive. It's a good business for us. We have testified and given a great deal of support for mass transit systems, for the mass transit bill, I think it's called, and I don't know what state it's in, but in Washington. And we have, in the past, done extensive research on mass transit. I don't know out here if you're as familiar with the Futurama. That was our display at the World's Fair, both in 1939 and in 1964, the two New York World's Fairs. We had exhibits at both of those entitled Metro Mobility, which discussed mass transit and traffic congestion and how to handle it.
We recently completed, as part of our a cooperative study with the University of Pennsylvania on urban transportation. We recently designed five special use vehicles that were designed and proposed for special uses just in the cities, limited use vehicles with various kinds of alternate power systems other than internal combustion engines. So we are very interested. It probably comes as a surprise to some people, but our idea of a utopia isn't everybody out in a traffic jam in a new Cadillac. Okay. Quite the contrary. Yes?
Is there any anticipation that the annual model change and various other forms planned out unless will be going on style?
Well, there are indications lately. First of all, we have probably over the last 6 or 8 years spread out the annual model change. For most of our vehicles now, it's I don't know what the word is, every 3-year model change, triennial or something like that, model change. We have, I think Ford and Chrysler and General Motors have said just more recently in the last few weeks and months that the full-scale type of
design changes that we see on cars today, which we saw very prevalently during the 50s and early 60s, are definitely a thing of the past. We've said that our new Vega car won't be materially redesigned for 5 years. So I think that just design changes alone will become what you probably would consider a thing of the past. We're not saying that we're never going to do them. We're going to do them. The annual model change as such certainly will still take place. What it will consist of will, for at least in the next few years, will be more internal change than external change, which I assume is what you mean. Well, when I said that, that's exactly what we did with our 1971 model cars. All the cars that we sell today, new model cars, have operate. We lowered the combustion ratio and the compression ratio, excuse me, so that these cars would be capable of operating on 91 octane fuel, leaded, unleaded, low leaded, whatever. It's our hope that people will use unleaded fuel with them. This is all our cars, whatever size. Now, we announced that we would do this about a year ago, February, and the oil industry began selling, marketing unleaded fuel. I don't know what kind of cars the state operates. For many of our cars, that was not a dramatic change. You know, small engine cars, the Chevy Nova offered a 4-cylinder engine. That would already. Most cars that worked on regular gas would work on 91 octane fuel. But in any event, all our 71 model cars do. Now, this eliminates lead particulate in the exhaust. The part I guess I left out that I should have covered was the most important reason we did this was because we have out of our 200 and some odd catalysts that we've tested, we've never found one that will work for any appreciable length of time with leaded fuel. The lead in the exhaust system renders the catalyst useless. It coats it. The particulate lead in the exhaust system coats the catalyst. Most of the ones we've worked with are pellets or beads in a pellet or bead form, and it coats them just like the chocolate is coated on an M&M by the candy part. So that in an effort to we know that when we put a catalytic converter on a car, it's going to have unleaded fuel to work. If you use leaded fuel, it won't work. We know that. And we wanted to, first of all, give the oil industry incentive and time to begin converting and installing unleaded fuel pumps in their stations around the country to get people in the habit of using it. And we're quite hopeful that they will do just that. Excuse me, yes. We will have a system of pollution controls, as I described. Perhaps some will have a different kind of carburation and not fuel injection. We don't know that all our cars will use fuel injection. Some will have different components, but we feel all of them will have what is necessary to bring about the reduction of emissions in the numbers in the areas that I said, beginning with
by our 1974 models, or late 74, or by our 1975 models. In late 1974, yes, we will have that equipment on the cars. This is, I don't mean to mislead you on this, this is when the next set of federal regulations take effect. Nationwide, January 1st, 1975, although there is a provision for a one-year extension. Well, last year, even with a two-month strike, we spent $113 million on research and development of pollution control systems. We spent an additional $25 million on installation of pollution control equipment at our factories to work on water and air pollution from our factories. We spent $113 million on pollution control systems for our vehicles. This year, we expect to spend somewhere around $125 million on research and development of pollution control systems for our vehicles and $60 million at our factories. That's the only 2 years that I know the outlay for. I would think that it has gone up gradually from 1965, and I would think that maybe back as far as 1960 it might be doubled. I really haven't got an estimate. On this subject, of course, maybe some people are rightly skeptical about whether we're doing all we can or as much as we can or what. This much I can say. It isn't a question of spending money. In an interview with the Thank you. In an interview with the Wall Street Journal about a month ago, our chairman was asked this question, and it was pursued rather vigorously by the two reporters. And he said to them, "How much do you think we should spend?" I think they said 1% of sales, which would be about $250 million. He said, "If I thought we could end the problem for $250 million, I'd give you the check right now." So it isn't a question of money. We know many examples in the country where large expenditures of money haven't solved any problem. I'm sure anyone can think of 2 or 3 easy ones. There is not a lot of technical expertise in this field. There aren't among our many unemployed people in the nation are not experts in air pollution control. Among the people that can't sell their product are not people with equipment to develop air pollution control systems. As a matter of fact, our research laboratory staff holds more patents in developing air pollution control equipment than anybody else in the country. The study of air chemistry is, as I said, about 20 years old. First, we found out it was a problem, then we had to come up with exactly what the problem was. So a lot of times, measuring equipment, as I said, had to be developed. I don't know if I convinced you that it's rather difficult to measure something that's 1 part per billion, or 1 part per million, but that's a kind of small measurement. So, yeah, you had another question? Well, there's no doubt that no matter what it is you're doing in a business or any other aspect of your life, everything has a matter of priorities on it. You can't do everything all at once. Whether or not we could have spent more money back in 1958, I don't really know. Whether we could have spent money in 1930 and found out the problem, I don't really know. All I know is that over the last few years that I'm familiar with and that we have publicly stated, we're spending whatever is necessary to do this job. That's the only point I can hope to impress on you, is that there isn't something somewhere that we could buy that would help us that we aren't buying because we're trying to save the money. There isn't, whether that be a piece of equipment, hardware, invention, or person. We're spending all we can. We don't think that we're perfect in this area by any means, but we think there's a lot of people that aren't doing that. Yes, right here in the yellow shirt. Well, yeah, those are aerospace engineers. I don't know that any of them know anything about pollution control. Perhaps they do, perhaps they don't. I don't really know. But there's no doubt that there's people out of work that could probably, learn. I can only say that, if you spend so much money and so much time on a given problem, doubling the amount of time, money spent, and the amount of manpower applied doesn't necessarily mean you solve the problem in half the time. Cure of cancer would have been solved a long time ago, Sheer outlay of money is no solution to any problem. I mean, we've proven that over in Vietnam. We've proved it with the welfare system. We've proved it in a lot of places, that just to spend money doesn't solve the problem. Unless it's properly spent, you aren't getting anywhere. We think this is how much that can be properly spent. Well, in general, what I can say is that, as you well know, this is a very competitive business. And I realize that people that imagine conspiracies in our business tend to think of the entire business as being General Motors and maybe Ford and Chrysler. But as we've learned all too painfully in recent years, there's a lot of people that make cars that don't even live in the United States. There's the Germans, the English, the Japanese now, and if some guy has some invention that would solve air pollution, and we say to him, we don't want it, and we just can't afford to do that. If it's a real thing, we just can't afford to do that. Where are we going to be when somebody else gets it? There's a lot more automobile companies than people tend to think, and imagining a worldwide conspiracy amongst them all, that's just more than I can comprehend. You're free to do it, I suppose, but it's more than I can comprehend. They also tend to think that out of the three companies, there's only three companies and there's only three people working for them. There's a well-known slogan that a secret is something known only by one person. Well, there certainly is. They are not all dedicated to keeping the internal combustion engine. Initially, the way we feel is that with what we know about the internal combustion engine, what we know about its exhaust makeup, we can do the best job of controlling it. We're hopeful that if we can do that, and as we say, if that's acceptable along the way, that it wouldn't be necessary to change it. We have no compulsion not to change to some other kind of propulsion system if it's truly an alternative. We have had a staff group in our scientific laboratory, in our research laboratory, and they've built and operated vehicles propelled by every kind of propulsion system we know of, that we've ever heard of. Their activities go all the way back to the beginning of General Motors in the early 1920s when they were established. We know of a lot of ways to make a vehicle move from one place to the other. At the present time, we don't know any that do it with all the features that the present engine does. By that features, I mean as efficiently and as economically and with a system that, can be mass-produced, can be maintained, can be operated under all kinds of conditions at a reasonable cost or at a near reasonable cost. No one would argue that the price of cars is low by any means, but it's as low. None of the other alternatives are any cheaper. So that's basically the way we feel about the internal combustion system.